Okay, class, welcome to Unit 2. The first day we'll talk about rate of change. So my learning targets for today is figuring out how I can determine rate of change and writing equations of tangent or secant lines. So the first idea is going back to linear functions. Y equals mx plus b, everyone's comfortable with, where the m always stands for slope. And the one thing about y equals mx plus b is that it's nice, but you need to know the y-intercept. That's not always going to be apparent. So the y-intercept is always going to be something 0, comma b, and it's one special point on the graph. Another way to write things is point slope form, and I actually like this way much better. Point slope form, y equals m parentheses x minus x1 plus y1, or you could write it the other way by putting the y1 up front. And the idea with this, I could use any point on the graph, not just the y-intercept. And if we really extend it a little bit farther, I could write it with function notation like this, where the y1 value is just the value of the function when I plug in x1. So just because I don't give you a y1 value doesn't mean you can't find it. You might have to plug x into the function to figure it out. So this unit is going to deal with building on calculus and what is the most important characteristic of this type of function, and the most important idea is slope. Slope is so important because it measures change. Now we're used to doing slope between 2 points, and we're going to talk about how we can make it a little bit different today. But the idea is that slope is so important because it measures how things are changing. And I think everyone knows the formula for slope. M is change in y over change in x. y2 minus y1 over x2 minus x1. Hopefully everyone knows that by heart. And to put a fancy name to it, we call this the difference quotient. Rate of change plays a role in the relationship between any two changing quantities. It's important to know. So another rate of change is a fancy name for slope. So linear functions have a constant rate of change, what we call slope, okay, for its entire function. So if a line has a slope of 2, the slope is 2 everywhere. It will never change. Whatever it is between any 2 points, it's the same between all 2 points. But all functions can have an average rate of change between any 2 points on a graph. So we want to draw a graph, and here's some function. If I have a point here, and I have a point here, that guy there is the average rate of change. I'm going to use ROC for rate of change. I'm not writing out rate of change every single time. Simple question. You do 240 miles in 4 hours. What's your average rate of change? Well, my average ROC is equal to 240 miles over 4 hours, or what we call 60 miles per hour. Does that mean you travel that the whole time? No. At times, you could have gone faster or slower. But you averaged 60 miles per hour for the 4 hours. Again, a graph of this. If this is time and this is your distance, and after 4 hours you're at 240 miles, your graph could have been something like this. That could have been how your speed or velocity was changing, but this is your average rate of change that was equal to 60 miles per hour. So this page is going to talk about the difference between a secant line and a tangent line. A secant line is a line that passes through 2 points on a function, and a tangent line is a line that just barely touches a function at 1 point. So you can see on this graph the difference between the two, and we're going to work on calculating the average rate of change for the secant line, and maybe what we call the instantaneous rate of change for the tangent line. If you recall your freshman physics class, you did this all the time when you did velocities. Okay, now I have this really random graph that I drew, and you can first see I have a secant line here between points A and B on the curve, so it's a line connecting 2 points on the curve, and the average rate of change is the slope of the secant line. So this slope here is the average rate of change between 2 points, in this case between points A and point B. Okay, so the average rate of change is just slope, and we do this slope formula, changing y over change in x. On the top here is this tangent line, and the tangent line is an instantaneous rate of change. So this slope here is the instantaneous rate of change at 1 point. In this case, at point C. That tangent line is the tangent line just through point C. Okay, so for this line, you can see that this tangent line and the secant line are parallel to each other. And what does that mean? When things are parallel to each other, that means these two red lines, one being the secant line, one being the tangent line, they have the same slope. Let's try an example. Well, first I'm going to complete this table using this function, and then I'm going to draw its graph on the right. So you can see, to the best of my ability, I've completed the table, plotted all the points, and drawn my parabola. Hopefully you've drawn x squared sometime in your life. It's not that hard. So now I'm going to take this graph, I'm going to do part B and part C. So for part B, I need to find the average rate of change between x equals 1 and x equals 3. So for x equals 1, I have y is equal to 1, so I have the point 1, 1. For x is equal to 3, I have y is equal to 9. I have the point 9, I have the point 3, 9. And my rate of change is just change in y over change in x. So I have my rate of change is equal to 8 over 2. My rate of change is equal to 4. Or my slope is equal to 4. But it also asked to draw this secant line. So I'm going to draw it. So you can see that I took my 2 points 1, 1 and 3, 9. I drew the secant line between those 2 points, and that slope of that blue line B is 4. Now I'm asked to write the equation of the secant line, and when I write the equation of the secant line, I use this form, the point slope form. I don't have to do y equals mx plus b. I could, it's just more work. So I'm going to use 1, 1, y equals 4 is my slope, x minus 1 plus 1. Or if I wanted to use 3, 9, y equals 4, x minus 3 plus 9. Now I want to draw something that's parallel. I want to draw the parallel line, the tangent line that is parallel. That means I have to have the same slope. Well, that means my slope, or my rate of change, has to equal 4. Now, if you're going to be in class, and hopefully it's going to be hard, but I'm going to take a ruler and go over the blue line and move it until I get tangent to the parabola. And if I do that very carefully, I get that tangent line. I'm going to label this C, and I see that it goes through points 2, 4. So now when I write the equation, I'm going to use that same form as before. So it's going to be y equals 4, x minus 2 plus 4 is the equation of that red line labeled C. Okay, I'm still going to use the graph even though it's off my screen. So when I have x equals negative 3, y equals 9, negative 3, 9. When x equals 1, y equals 1, 1, 1. My rate of change is change in y over change in x. I get 8 over negative 4, so my rate of change is equal to negative 2. That is my slope. I'm going to go to the graph and draw this. So here are my 2 points. Here is 1, 1, negative 3, 9. I'm going to draw this line. This is line D, and I could tell. And then when I write the equation, it depends which points we're going to use. I could use slope of negative 2, use the point I circled in gray, or I could use 1, 1, which is an easy one to use. And that is the equation of that blue line labeled D. Now I'm going to do the tangent line. So again, I'm going to use my ruler and just move it parallel. And if I do that carefully, I should get this parallel line. I'm going to label it E, and I can see that it goes through this point right here, which is negative 1, 1. So again, parallel is the same slope. So my ROC is equal to negative 2, and I see that it goes through negative 1, 1. So my equation is going to be y equals negative 2, x plus 1 plus 1. And that is the equation of that red line labeled E. So another way to look at this is this graph where I have x is the first point that I want to look at, x plus h, because the distance between these two x values is just a distance of h, and I'm using these points A and B. So I'm trying to figure out the average rate of change between points A and B. And I'm going to figure out that formula, and you can see the formula is already there. Let's talk about what we have. Well, point A, put a little arrow, will be my x1, y1. Point B is my x2 and my y2. Okay, but let's put it in terms of what we have here. X and x plus h as our input values. So this point here is x, because that's the x value, and when I plug it into the function I get f of x. And when I do that over here, this x value is x plus h, and when I plug it in the function I get f of x plus h. And that's kind of how I get this formula right here. Because this formula is still the change in y over change in x, or y2 minus y1 over x2 minus x1. So over here, this is what we're going to do. The average rate of change between those two x values is equal to this formula, and we're going to work with this formula. And this is a formula we're going to practice a lot, all the time. So to expand it any more, if I have these are my 2 points on the graph. This is where point A is at. This is where point B is at. So right here, this is the formula I'm going to use. And you can see in the denominator right away that these x's will cancel, and I really just kind of use this formula in general. We call this the difference quotient because it's still this change in y over change in x, or y2 minus y1 over x2 minus x1, and we need to do this in this order. This is going to be a key. And I'll go through some examples. It's going to be a lot of algebra, and you have to do it in steps. There's no shortcuts. It's going to take 4 or 5 steps. Do not think you can consolidate it. I need to see the work. Okay, we have this example where we're going to use the function x squared plus 1. We're going to find the average rate of change, or the change in y over change in x. And the first one's really easy. It's just numbers, plugging things in. So my f of negative 1, I have to figure out. I have to figure out my f of 3, because those are my x values. And when I do all that, I get 2. And when I do it here, I get 10. So I have the ordered pairs, negative 1, 2, and 3, 10. And when I figure out my rate of change, I get 10 minus 2 over 3 minus a negative 1. I get 8 over 4. So I get a rate of change is equal to 2. That's pretty easy. Next one's a little bit harder because I have variables a and b. It's going to be a little bit harder. So I have to plug those in. I'm going to go off camera to do that. So when I plug a and b into the original function x squared plus 1, I get these ordered pairs. I'm still going to do the same thing. y2 minus y1 over x2 minus x1. So y2 is b squared plus 1 minus, and because there's more than one term in here, I better put parentheses around it, a squared plus 1 over b minus a. I get rid of the negative sign by distributing. B squared plus 1 minus a squared minus 1 over b minus a. And we're going to see this trend is that when I have variables in there, numbers are going to cancel out, and the ones cancel out. And right now I have b squared minus a squared over b minus a. Okay, right now there's nothing you could cancel out. Right now. Okay, you cannot cancel things out when you have subtraction going on in between them. You need to factor things. Hopefully you recognize the numerator as b plus a, b minus a, and you have b minus a in the bottom, and technically there's parentheses around it. And now I can cancel things out because b minus a is identical top and bottom, so I get my rate of change is equal to b plus a. It's a little bit harder when we're working with variables, but it's not that hard. You have to remember about factoring. Okay, I started this last one, and you can see that my input here is x, and I plug it in there, I get x squared plus 1. My input here is x plus h, I plug it in, I get parentheses x plus h squared plus 1, and I'm going to still do the same thing, y2 minus y1 over x2 minus x1. So I set it up as y2 minus y1, parentheses around that, over x2 minus x1. So when I get here, I need to expand it. I need to expand this to get rid of the parentheses. So you need to remember that x plus h squared is x plus h times x plus h, which is equal to x squared plus xh plus another xh plus h squared. And I get x plus h squared is equal to x squared plus 2xh plus h squared. And I'm going to put this in a box because you better remember this. You need to know this all year. Memorize it. Put it on a note card. Put it on your bathroom mirror so when you're brushing your teeth it's staring at you and you memorize it. So when I expand all this out, I get my rate of change is equal to x squared plus 2xh plus h squared plus 1 minus x squared minus 1 when I distribute the negative sign plus x over x plus h minus x. This is my favorite step coming up right now. I get to cancel thing in the numerator and denominator. And I'll tell you right now, everything that does not have an h should cancel. So negative 1 does not have an h, and it's got a buddy here, 1. They cancel. Minus x squared does not have an h, it has a buddy here, x squared. Now if we rewrite this, oh, and on the bottom, these x's don't have h's, they cancel. So I get my rate of change is equal to 2xh plus h squared over 1h. I'm going to factor a little bit. I'm going to take an h out, but I'm going to talk about what we can do instead on the next problem. Plus h over h, and I realize these h's can cancel out. I get my rate of change is equal to 2x plus h. Okay, this last problem again is going to be a lot of algebra, but if you keep everything straight, it's multiple steps, it's not so bad. I'm using this bigger function x squared plus 5x minus 2. And my rate of change is f of x plus h minus f of x. Please do that order. The f of x plus h has to come first over x plus h minus x. But I could tell the x's cancel out right away, so really on the denominator, all I really have is h. Okay, so what I'm going to do is plug x plus h into this function for the x's. So I get x plus h squared plus 5x plus h minus 2. And now I have to subtract the original function. It says subtract the original f of x, parentheses, x squared plus 5x minus 2. Okay, now I have to expand everything. And we just talked about x plus h squared is right here. You could even see it on the screen, is x squared plus 2xh plus h squared. I distribute my 5 plus 5x plus 5h minus 2. I distribute my negative sign, and it becomes minus x squared minus 5x plus 2 all over h. Again, now comes my favorite step. We'll do it in black. This big long numerator. This is a big long numerator. All terms with no h will cancel. I'm going to do it from reverse. 2 does not have an h. There's a negative 2 that cancels it. Minus 5x does not have an h. It has a positive 5x. Negative x squared does not have an h. It has an x squared here. And when you're done, you get 2xh plus h squared plus 5h over h. You get to this canceling out the numerator, and you don't have all the terms with an h, without an h canceled out. You did something wrong. That's your self-check. Now when I see this on the bottom, I'm dividing by h. So that means I could cancel 1h everywhere. So I'm going to divide every term by h. So this h cancels out. I cancel out 1h here, I cancel out 1h here, I cancel out 1h here. And I get my rate of change is equal to 2x plus h plus 5. Or, if you do want to factor it, you could factor this numerator, and you get h 2x plus h plus 5, and you get an h on the bottom, and you do see that these h's cancel out, and you get the same result. So I factor when I have to, but I recognize that this 1h is canceling out 1h everywhere. I cancel out 1h here, I cancel out 1h here, becomes like an h to the first. I cancel out 1h here. I get my rate of change of 2x plus h plus 5. And like I said, it took me 1, 2, 3, 4. It took me like 5 steps. Okay, thank you very much.